Hello, welcome to WinGenKits.com. This video is one part of a series of videos intended to demonstrate some of the construction methods and techniques used by the do-it-yourselfer who is interested in designing, building, and using wind turbines for producing electricity. In this video, I'll narrate the process of making the coil assembly used in an axial flux alternator. In order to wind coils, you're going to need a coil winder. You can make this fixture yourself out of common materials laying around your shop or from the local hardware store. It can be as simple or as elaborate as your imagination allows. The actual size and shape of the coils is determined by the spacing and length of these bushings. Suggested dimensions for this pattern are available on our website. Securely mount the coil winder to a sturdy workbench. Then secure a rod to the workbench, which will be used to hold spools of magnet wire. In some cases, it might be beneficial to wind multiple strands of smaller wire instead of one large strand of single wire. You don't necessarily need to have multiple spools of wire if you want to do this. For example, with one spool of wire, you can pre-cut several lengths and carefully lay them across the shop floor. Then wind them all together. Develop a consistent procedure and wind all of the coils in the same direction. At this point, it doesn't matter which direction, just as long as they are all the same. After about 20 or 30 turns, adjust the shape of the coil by squeezing the sides. This is to help maintain that the sides are straight and that the coils all fit together. It's important that all of the coils are exactly the same, so be sure to count the number of turns carefully. This is a simple but very helpful tool used for taping the coils before removing them from the fixture. It's just a thin strip of metal that's been bent by hand. Slip it under the coils and use it to pull the tape back through. After two sides of the coil are taped together, carefully remove it from the fixture, then tape the third side. Before moving on and making the rest of the coils, it's important to check the dimensions of this coil so that it fits inside a predetermined pattern. This will assure us that all 9 coils will fit together. Then make the rest of the coils. This is another simple fixture that you should make in your shop. A full-size pattern can be downloaded from our website. The fixture is used to temporarily hold the coils in place while they're taped and soldered together. When placing the coils on the fixture, be sure that the winding direction is the same for all of the coils. Then tape them together. Refer to the wiring diagram on our website to connect the coils together in a 3-phase star configuration. When making the solder joints, place them in between two adjacent coils. This gives them a little extra space where they can be tucked away cleanly. Next, use a propane torch to carefully burn away the insulation on the wire where it's going to be soldered. Then use fine sandpaper or steel wool to clean the ends of the wire, exposing the bare copper. Twist the ends together, then solder. Repeat this process for all of the connections. Organize all of the wires on the outside of the perimeter, turning the solder joints inside, and then tape everything in place. The final step is to solder the terminal buttons in place. They are specifically designed to be cast inside the stator with the coils for the purpose of providing a clean and flush electrical connection. And this is the completed coil assembly, ready for casting. We're going to show you how to do that in the next video. We hope this video has been helpful, and here at windgenkits.com, we thank you for watching. Hi, welcome back. In the first video, we wound the coils and then soldered them together to make the coil assembly. In this video, we're going to take the coils and cast them in a fiberglass resin to make the stator. So let's get started. For convenience, this is the stator mold that we offer from our website. Being a do-it-yourselfer, this is something that you can easily make. We use a laminate material which allows the stator to release easily after molding and provides a great surface finish. The coil assembly should fit snugly around the center core, which will keep it in perfect alignment inside the stator. Determine the location for the terminal buttons. Then drill a hole through the bottom plate, which will allow these to be bolted into place. In this next step, use tape to seal all of the open edges inside the mold. Take special care to make sure that all of the edges are sealed and that the tape is smooth and free of wrinkles. Use your favorite automotive car wax as a mold release and thoroughly coat all of the parts of the mold. Put a mark on the edges of the parts. This way you'll know how it goes together later on. Carefully lay out the fiberglass cloth, then roughly cut a square piece that fits the base of the mold. Then cut a circular piece which will fit inside the mold cavity. The square piece of fiberglass cloth then gets sandwiched in between the base and the center section of the mold. Secure the parts together with the screws provided. Then make openings through the fabric for each of the bolt holes. Install all of the bolts and washers, and now the mold is ready for casting. The coils need to be cleaned from all oils and contaminants. Most of this is from the soldering process. Use an evaporating solvent and wire brush to clean everything up. Now we can set the coil assembly inside the mold. Secure the terminal buttons in place through the screw holes that we drilled previously. Our stator casting resin is a special two-part epoxy that features an extended pot life, thin viscosity, and low odor. It mixes in a 3-to-1 ratio, which is easily done with the convenient dispensing pumps. Pour some of the resin over the coils. Then carefully work the resin into the fiberglass cloth, making sure that it's fully saturated, and remove as many air pockets as possible. Our resin casting system makes it easy to mix the resin as it's needed. This helps eliminate any waste. Lay the circular piece of fiberglass cloth over the coils and continue to work it into the resin. At this point, it is not important to fill the mold all the way to the top, but do try to work out as many air pockets as possible. Then put the cover on the mold and tighten all the bolts. It's normal for resin to start squeezing out through the edges. Incline the mold with the filler hole at the top and gently tap on it to help release any remaining air bubbles still trapped inside. Add more resin as needed and repeat this process several times until all of the air bubbles have been removed. Then let it sit so the resin can cure. After the resin has cured for a day or two, remove all of the bolts from the mold and carefully open it up. After the stator has been removed, carefully trim the edges. Carefully cut through the fiberglass and remove the center core. Remove all of the tape and clean the edges with sandpaper. Then scrape the fiberglass off of the terminal buttons and clean these with sandpaper as well. Wow, this stator turned out really nice, and I'm sure that yours will too. In the next video, we're going to build the rotors, and that will complete our alternator. I hope this has been helpful, and thank you for watching. The rotor assembly is probably the easiest part in building a permanent magnet axial flux alternator. However, there are a few procedures in doing this that might be a little tricky or even hazardous, and we're going to try and cover some of those details in this video. We also have additional comments and suggestions in the tutorial section on our website, so feel free to visit there for that information. So let's get started.
The rotor assembly of an axial flux alternator should be based on two steel discs with magnets. The steel discs capture magnetic flux that would normally be unused and concentrates it in the field between two opposite magnetic poles. The magnets are arranged in a north-south, north-south pattern around the circumference of the discs. When the discs are assembled, opposite poles face each other. This structure manipulates the magnetic field to direct the maximum amount of energy through the coils of the stator. Our 9-inch rotor kits include two steel discs with an aluminum spacer. We machine the spacers on state-of-the-art CNC machinery. The discs are precisely laser cut. They have indicator notches every 30 degrees on the circumference to be used as an alignment guide when setting the magnets. On a clean workbench, gather the needed shop supplies such as safety glasses, acetone, a degreaser, rags, epoxy, and so on. Clean the discs to remove any dirt and oil from the surface. Wear gloves so that the oils from your hands won't transfer to the disc. Follow the instructions provided with the epoxy for surface prep procedures. Using the notches as guides, draw layout lines on the discs. These will be used for aligning the magnets. The magnets will also need to be degreased before they are glued in place. Due to the high strength of the magnets, it is best to bring them into contact with the disc edge before setting the magnet on the disc surface. We recommend you practice this several times before actually using the epoxy. Mix the epoxy according to the manufacturer's instructions and pay attention to the working time allowed. There are many suitable epoxies for this application. Refer to our website for more details and recommendations. Apply a thin film of epoxy to the disc and set a magnet in place. The magnet should be centered on the layout line. Once the magnets are set in the epoxy, they'll float around for a minute or two. When enough epoxy is squeezed out, they will remain in place. When setting the next magnet, it is important to set it with the opposite pole facing up in order to achieve the north-south, north-south pattern. Find the face that repels the previous magnet to determine which face should be down. The face that repels the previous magnet should be glued to the disc. Continue with this procedure to set all of the magnets on both discs. When starting on the second disc, it doesn't matter if you start with a north pole or a south pole, just as long as you achieve the north-south, north-south pattern when finished. You should clean up excess epoxy with acetone. Then follow the epoxy manufacturer's instructions to allow the adhesive to cure to its full strength. Bolt the center spacer in place with the hardware provided. Our TriStar bearing carrier comes with the rotating assembly kits and can also be purchased separately. It is pre-machined to bolt directly to the rotor assembly. The TriStar plate is also designed for mounting a flange bearing, spokes, or blades. If you use this component, bolt it to the rotor assembly at this point. Place the stator over the spacer. Stack several wood blocks to support the second rotor when it's lowered into position. Never put your finger under the opposing rotors, as this may cause injury. You can use a magnet, for example, to keep your finger from being pinched. Look to see if the bolt holes line up. If not, rotate the rotor until they do. The unique design of the rotor bolt pattern assures that it will line up as long as the magnets are in the north-south, north-south pattern. Use more wood blocks to support the upper rotor as you carefully lower it into position by removing other blocks. As the rotors get closer to each other, their attractive force increases and they will become very difficult to pull apart. Never allow them to come together without a spacer in between. Loosely install the bolts and continue to carefully lower the upper rotor by removing blocks. Once in place, tighten the bolts.
With the stator in place, this alternator is complete and ready to make electricity. In another video, we're going to go back into the shop and mount this in a test fixture where we can study some of its performance. In the meantime, we hope that this video has been helpful, and as always, we thank you for watching.